Today, we're going to be going over quadratic and exponential word problems. Now, these are worth about 20 points on your average SAT, so an important concept to know. Our approach to these is going to be to identify quadratic and exponential word problems questions. We're going to break down the question. We're going to build a formula to solve them, and we're going to solve a practice question together. So these questions will give either a quadratic or an exponential equation, and they're often modeling a situation such as an object falling maybe, or being kicked. So something that is going to give us kind of like a parabola or exponential shaped graph, and I'll show you what this means in 1 second. So our formula on these is going to be step number 1, we're going to understand the situation they're giving us. Step number 2, we're going to find our quadratic. And step number 3, we're going to apply the quadratic to our situation. So here's an example. A quadratic function models a projectile's height in meters above the ground in terms of time in seconds after it was launched. The model estimates that the projectile was launched from an initial height of 5 meters above the ground and reached a maximum height of 45.6 meters above the ground 2 seconds after the launch. How many seconds after the launch does the model estimate the projectile will return to a height of 2 meters? Okay, so let's understand our situation. So we have a quadratic function that's modeling a projectile's height in meters, and the projectile was launched from an initial height of 5 meters. And then it reached its maximum of 45.6 meters after 2 seconds. It's asking us how many seconds is it going to take for the projectile to return to a height of 5 meters. So I'm just going to draw a little bit about what I think the situation looks like. So our projectile starts here, goes up, comes back down. So starting at a height of 5 meters, and this is at time equals 0 seconds, and then here at time equals 2 seconds, exactly halfway through our parabola, it's going to be at 45.6 meters. Now, what we need to know for this problem is that a parabola has equal time on both halves of it, and so if it reaches its maximum, which the maximum will be the exact middle point of a parabola, or minimum would be the exact middle point of a parabola, then it'll take the exact same amount of time to get from 0 to 2 seconds and 5 meters to 45.6 meters as it will to get from the 45.6 meters back to 5 meters. So if it took us 2 seconds here, it's going to take us 2 seconds here. And just to reiterate, the reason that it's 2 seconds on both sides is because our parabola is uniform. And so if we have the maximum point, which we know mathematically has to be the middle point in our parabola, then the time on both sides has to be equal. And since it started at 5 meters and we're looking for when it's going to get back to 5 meters, it's going to be the same amount of times it took it to get halfway. Okay, so if we know that it took 2 seconds to get to the halfway point, and it also took 2 seconds to get back to 5 meters, our total time elapsed from when we launched it is going to be 4 seconds. And you have to be careful to understand what you're looking for in these. And what we're looking for is how many seconds after launch does the model estimate the projectile will return to a height of 4 meters. So again, it took us 2 seconds to get to the halfway point and another 2 seconds to get back to 5 meters. So our total is going to be 4 seconds. This problem is a good example of how the SAT is getting better at writing questions that you can't really use Desmos for. So this one was a little bit more theoretical. We needed to know that the maximum point is where a parabola is split in two. And so for this one, Desmos we really couldn't have used, but make sure if they do give you an equation, you're plugging it into Desmos and you're getting the right answer. Good luck on these.